Hello, this is Solving Inequalities, Compound Inequalities, Example 6. Example 6 is this story problem and talks about the planet Mars, and the temperature where these robots land can range from minus 100 degrees Celsius to 0 degrees Celsius. And they want us to write an inequality, but it has to be in degrees Fahrenheit at a landing site. Now I'm going to do this question quite a bit differently from the book. You can follow along in the book. They do a good job, but it just doesn't make sense to me the way they do it. Anyway, it says that this temperature can range from minus 100 all the way up to 0. So that would mean this temperature has to be greater than or equal to 100, negative 100, and this temperature in degrees Celsius also is less than or equal to 0. So graphing that, if we graph it, negative 100 is over here, and 0 is over here. This has got to be greater than or equal to negative 100, so that's this way, and less than 0, so that's this way, and graphing this, we do get an AND condition. This is the most sure way to figure out if you have an AND condition or an OR condition. And it's an AND condition because the graph is in the middle. So it's an AND condition, so I can put this together. And this is going to be T, and the wide open part toward the T, and this time the pointy part toward the T, and I have T is greater than or equal to negative 100, and T is less than or equal to 0. So now the question says to do this in degrees Fahrenheit. So to do this in degrees Fahrenheit, I'm going to leave, so this is in degrees Celsius. And to switch it to degrees Fahrenheit, well, I know what 0 degrees Celsius is in Fahrenheit. That's 32, the freezing point. All we have to do is figure out what negative 100 is in degrees Fahrenheit. And they do give us the formula in the book. They say this is the formula. This is degrees Celsius, and this is the degrees Fahrenheit. And the degrees Celsius we're trying to figure out is negative 100. So we have negative 100 equals 5/9 F minus 32. So here we have an equation to figure out for F. And I'll just work this like I would any equation. I'm going to get the variables all on this side. So I have 5/9 times F minus 32 equals negative 100. I'm tempted to distribute this 5/9, but I think I would end up with quite a few fractions. So I think I will divide both sides by 5/9. So I have to do negative 100 divided by 5/9. And that's negative 180. So F minus 32 equals negative 180. So now F equals, I'll just add 32. So I'm going to do plus 32, and that's negative 148. So I've figured out that negative 100 in degrees Celsius is the same thing as negative 148 in degrees Fahrenheit. And that's my solution. And to graph this, and this is in degrees Fahrenheit. So to graph this, if I have negative 148 over here and 32 over here, t is greater than or equal to negative 148, so a solid thing there, and it goes this way for everything greater. T is less than 32, less than or equal to, so solid on the positive 32, and the graph is that way. So this graphs everything between these two, and it's definitely an AND condition. And let's see what else. Solve the inequality. We did that. We graphed the solution. Identify 3 possible temperatures in degrees Fahrenheit at the landing site. Well, we can get this from the graph. Any 3 numbers in between here. Answers are definitely going to vary here. We need a number greater than negative 148, so that might be negative 125. 0 is certainly in there, and so is positive 25. Those are 3 possibilities.